Hello, students. I've been asked about the combinatorics proof questions a couple of times, and I thought I'd just kind of break it down for anybody that's interested. Now, of course, the whole idea of these types of questions is to show that one side is the same as the other. So at the end, we should be able to say the left-hand equation, which is this one, is equal to the right-hand equation. And if we can do that, then we've achieved what we wanted to achieve. So this is our goal. Now, algebraically, what we're trying to do then is manipulate. So logically, if we use our combination rule for each of these, on our left-hand equation, we've got n factorial, and k factorial, and n take k factorial. And on the right-hand equation, we've got n take 1 factorial, and k take 1 factorial. And if we think about what n take 1 take away k take 1 is equal to, then we end up with n take 1 take k plus 1. So we expand that negative 1 out. And that works out to be, because the negative 1 and the plus 1 cancel, just n take k. So this is n take k factorial. And then we have n take 1 factorial. And on the bottom we'll have k factorial. And then we've got another one of these to think about. We've got n take 1 take k. Now, that's probably not the best way to look at it. We can say that's the same as n take k take 1. And so that's the best way to look at it. N take k take 1 factorial. Now, the reason this is the best way to look at it, because it relates back to this n take k here. Now, what our approach has to be is we want the denominators to be the same. So let's highlight our issues. Our issue is this one here. We want that one to be k factorial as well. And we want this guy here to be n take k. So these are the points of difference, and they're the ones that we need to fix. So just working with this right-hand equation for a second. Well, this k factorial needs to be k, and then k take 1, and so on. So we can call that k take 1 factorial. So we can see, in order to turn this into k factorial, we need to multiply it by k. And in order to turn this one here into n take k factorial, we'll have n take k multiplied by n take k take 1, and so on. So this one here needs to be multiplied by this n take k on top and bottom. So we'll have our n take 1 factorial. We've got k take 1 factorial and n take k factorial. And in order to turn this into what we want, we're going to multiply by k on the bottom. And because we multiply by k on the bottom, we'll do it on top, so we don't unbalance it. And with this n take 1 factorial, we've got our k factorial, and then n take k take 1 factorial. We need to multiply this one by n take k on the bottom. And if we do that, this becomes n take k factorial. And so because we did this on the denominator, we also do it on the numerator. And what that does is it allows us to simplify it into n take 1 factorial times k over k factorial n take k factorial. And on this side, we'll have n take 1 factorial multiplied by n take k, and all over k factorial n take k factorial. Now, if we look at both sides here, we're in this really happy spot where all the denominators are the same. So if it makes us feel better, we can go, well, if we multiply everything by those three, then we can cancel them. And this only happens when they're all the same. And then we can say we're looking to show that n factorial is equal to n take 1 factorial times k, and n take 1 factorial n take k. Now, where we're at algebraically at the moment, the secret all lies over here. So this n factorial is the same as n multiplied by n take 1 factorial. Now, if we do that, we end up with a common n take 1 factorial with every term. And once we do that, we can divide everything by n take 1 factorial. And we're left with a much simpler expression or equation. We have n is equal to k plus n take k. Now it's very obvious now that those k's will cancel, and we're left with n is equal to n, or we've shown that the left-hand equation is equal to the right-hand equation. Now this isn't a formal proof, because a formal proof you will only adjust one side of the equation. So those ones are a little bit more algebraically complex, but we don't have to do that at this stage. As long as we can change both sides to equal each other, to prove that they are the same, then we've achieved what we wanted to achieve. Okay, hopefully that makes a little bit more sense about the goal and the process involved with these questions, particularly this skill here, where we're multiplying top and bottom in order to get that common denominator. That isn't always a process, but that process does make it a little bit easier. Okay, hopefully that makes sense. Thank you.